Okay, so basically what we're going to do is we're going to reiterate what equivalent fractions are. And when we go to add and subtract fractions, it's very important to be able to write equivalent fractions for multiple reasons. So truly, before we can move on, we have to be able to write equivalent fractions. So I broke it down a little further, and reminder, equivalent fractions are fractions that represent the same amount but have a different numerator and denominator. Okay, I'm going to try and relay that message in these examples here. So what they want us to do is write a fraction that's equivalent to 8 over 14. So here's the thing. This first pie has 14 pieces it's cut into. And we're going to basically shade in 8 of those 14. Okay? So that's 1, 2, 3, 4, 5, 6, 7, and 8. Now what we want to do is we want to go over here, right, and determine how much of this pie, right, has been eaten. And if I look here, right, there's 1, there's 2, there's 3. Does this look equivalent to that yet? No. We want this piece of pie to represent the same size as the piece of pie over here. So if I go one more over here, okay, if I look, 8 over 14 is equivalent to, if I cut this pizza up into 1, 2, 3, 4, 5, 6, 7 slices now, it would be equivalent to 4 out of 7. Okay, and if you think about it, does this piece of pie look to be the same size as this piece of pie? And I would say it does. Now look at what we did here. If I wanted to, write the equivalent fraction, what did I do to 14 to get 7? I divided it by 2. What did I do to 8 to get 4? I divided by 2. 8 divided by 2 is 4. 14 divided by 2 is 7. So that is an equivalent fraction. Now the next one, if you look at the first pie, is cut up into 6 slices. The second pie is cut up into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you know right away the number of pieces in the pie is your denominator. Now if I color in 5 of the 6, I ate that much of the pizza. Right? So if I look over here, if I shade in the same amount of pizza, right? If I look, we got one more to do. Now if you look, the remaining piece left. If I look, does this piece look to be the same as these two pieces put together? Yes. So when we go to write this equivalent fraction, how many pieces did we shade in over here? I shaded in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 12. And if you think about it, what did I do to 6 to get 12? Multiply by 2. What do I have to do to 5 to get 12 then? I'm going to go ahead and multiply by 2. That gives me 10. That gives me 12. Okay? Now the next one, right? This pizza was cut up into 15 slices. This pizza was cut up into 3. So right away, my denominator in the second one is going to be 3. So now if I color in 10 of the 15, So there's 1, there's 2, there's 3, 4, 5, 6, 7, 8, 9, 10. So right away here, this is how much of the pizza was eaten. Okay? So over here, if I duplicate that, right, that would be that slice and this slice here. So do these two yellow slices look the same? Yes. And if you look at the remaining piece, does that piece look to be equal to that piece? And the answer is yes. So right away when I look here, how many slices of the second pie, which is cut into 3, is shaded in yellow? 2. And if I look, 15 divided by 5 gives me 3. 10 divided by 5 gives me 2. I want you to take your time to do the you try problem. So pause the video, try the you try problem, and come back and check your answer. So the first pizza, right, basically has 2 pieces out of 7 filled in. That represents this fraction here. Now the second one is cut into 14 slices, right? So if you look, I shaded this piece is the same exact size as this piece. So how many of these, right, how many of the 14 slices did I have to shade in? That is 4. I could check my answer because 7 times what would give me 14? 7 times 2. 2 times 2 would give me 4, right? So going on to what we talked about yesterday, writing equivalent fractions, right? We talked about if we multiply any number by 1, you don't change anything, right? So 4 times 1 is 4. So if we have some fraction a over b, and I multiply the numerator by c, and I multiply the denominator by c, what happens is I get a fraction that looks different, but what you have to understand, the value is the same because I basically multiplied by 1. And the same thing happens if I have a over b and I divide by some number c and I divide by some number c, I would get ac or a divided by c over b divided by c. If I look again, basically I didn't change the value because I divided by 1. So how do we do this, right? Well, there's a couple of ways you can look at it. One, I know what I multiply 5 by to get 20. But if I do 20 divided by 5, I get 4. So that means I multiplied the denominator by 4. I have to multiply the numerator by 4. That's how I get this new number. 4 times 4 is 16. So remember, I have to multiply this to get this. Alright? So let's take another look. What do I have to do to 24 to get 12? Right? Using multiplication or division. Well, if I'm going from big to small, I know I'm dividing. 24 divided by what would give me 12? 2. So if I divide the numerator by 2, I'm going to divide the denominator by 2, and that gives me 36 divided by 2 is 18. Pause the video, do the you tries, number 1 and 2, and come back and check your answer. So, right here, what do I have to do to 7 to get 21? I'm going to multiply by 3. Multiply the numerator by 3, that gives me 15. Right? What do I have to do to 5 to get 20? Multiply by 4. Multiply the numerator by 4, and I get 16. Oops, sorry, I didn't realize that was the same problem. Okay, now, next, we're going to compare fractions. Right? What you have to know is that this is the less than symbol. This is the greater than symbol. And this means equals, right? You may have used these before, you may not have. But when we read anything, we read from left to right. So, when we compare fractions, we want here if I'm using the less than symbol, I'm trying to determine which fraction is bigger or smaller. Which fraction is bigger or smaller? So when I use the less than symbol, that's basically telling me, right, that the small number is less than, I'll use this symbol, the big number, right? Remember, picture this being an alligator. The alligator always eats the bigger amount. So here we're going to flip it and say the big is greater than the small, and equals mean they're equivalent. So we're going to start easy here. If I have 4 and 10, if I wanted to use one of these symbols to make a true statement, right, what symbol would I put in here? So here, which one's bigger? 4 or 10? 10 is. So we're going to make that alligator eat 10. So we would read this, 4 is less than 10. Over here, 12 and 8. 12 is bigger, so the alligator eats 12. So we say 12 is greater than 8. And over here, if we simplify this, we get 5. 10 over 2 is 5. Those are equal. Okay? But now when we add the element of fractions, it gets a little more complicated. So I started in baby steps here, right? Using the diagram. Here, this pizza was cut into 11 slices. And we have 3 of the 11. Here, this pizza was cut into 4 slices, and we ate 3 of the 4. Well, which one represents more of the pizza? The 3/4. So the alligator is going to eat 3/4. So 3/11 is less than 3/4. Over here, I have 3 out of 10 slices filled in. I have 2 out of 10 slices filled in. Which piece overall is bigger? The 3/10 piece or the 2/10 piece? The 3/10 piece. So we say 3/10 is greater than 2/10. Now, if I have 11 out of 11, that means I ate all 11 pieces. So I ate the whole pizza. Versus this person ate 4, 6. Who ate more here? The 11 out of 11. Okay? Now, drawing diagrams makes sense. But remember, the bigger the denominator, the smaller the slices. Right? The smaller the denominator, the bigger the pieces. So use that idea, right, in the you tries. Okay? So pause the video and do the you tries. And come back and check your answers. Here we have 2 out of 11 versus 2 out of 9. Remember, the pizza cut into 9 slices is bigger, so 2 out of 9 is obviously going to be bigger than 2 out of 11. Right? 1/12. Here's 1/12, 11/12. Right? Woo. Right? That should be very easy to understand. If your denominators are the same, the bigger numerator is the bigger amount. Here you have 5/8. 2, 3, 4, 5. Right? Here you have a half. Which one is bigger? If I look, these 3 pieces would be, or 4 pieces would be equal, but we go to 5, so 5/8 represents more. Now when we go to compare fractions, right, when you have the diagram, it makes it real easy. But what do we do if we don't have the diagram? What we do is we look for, we're going to write equivalent fractions so that the denominators are the same. Okay? So remember, then we basically just compare the numerators. So if we look up here, when we have the same denominators, right? 12 and 12, 11 twelfths was bigger because the pieces are cut in the same size. 11 slices is obviously going to be more than one slice. So here, when I have 3/4 and 1/2, you might already know that 3/4 of something is bigger than 1/2 of something, right? But if I look, can I rewrite both of these denominators using 4? So 3/4. How can I write this with the denominator of 4? What do I do to 2 to make 4? Multiply by 2, but then I have to multiply the numerator by 2. So this would be 3/4 compared to 2/4. Which denominator is or numerator is bigger? 3/4. So this would be what it looks like. 5/8 and 3/8. Our denominators are already the same. So you obviously, when you compare the numerators, 5 is bigger than 3. So 5/8 is greater than 3/8. Now, this is where it gets tough, right? I have to find a common denominator here. So what can I turn 3 and 4 both into, right? They both go into 12, don't they? And if you don't understand this problem, don't stress out. But what do I do to 3 to get 12, right? So I want to make this a 12. Multiply it by 4, multiply the numerator by 4, that would give you 8/12. What do I have to multiply 4 by to get 12? 3. Multiply the numerator by 3 and I get 9. Or when I go to compare these now, right, is 8/12 or 9/12 bigger? 9/12 is bigger. This one's pretty easy. 4/6. 2/3. I'm going to rewrite that using a denominator of, use a denominator of 6, right? What do I have to multiply 3 by to get 6? 2. Well, then what do I have to multiply 2 by? 2. So 4/6 and 2/3, what are those? These are equal. Then 3/8 and 5/16. What do I have to multiply 8 by to get 16? Multiply by 2. Multiply by 2. 6/16 compared to 5/16. 3/8 is bigger. Okay? So now, when I look at this, one thing you have to remember, it is always easier to make your small denominator, right? Turn that into a bigger denominator. Because the numerators might not always be divisible by a number. So here, do the U-tries, come back and check your answer. So here, I'm going to turn these into 8. So 4 times 2 gives me 8. So 2/4 versus 3/8. Oh, sorry, 2/8 versus 3/8. 3/8 is bigger than 1/4. 7/16 and 1/2. I'm going to turn 1/2 into a denominator of 16. That's going to be times 8 times 8. So 7/16 versus 8/16. 8/16 is bigger. So 7/16 is less than 1/2. Here, turn 4/5 into a denominator of 15. Multiply by 3. Multiply by 3 gives you 12/15. Therefore, 12/15 compared to 7/15, that means 12/15 is greater than 7/15, so 4/5 is greater than 7/15. So, do me a favor, right? After you're done with the notes, do the homework and go ahead and